everybody. Today we're going to talk about mammals. Living mammals belong to three clades: the monotremata, or egg-laying mammals, the metatheria, or marsupials, or pouched mammals, and the eutheria, or placental mammals. How do you know a mammal if it walks in the room? It's hairy, right? Not if you're a paleontologist. You gotta know it from the teeth and the bones. First thing, teeth. Mammals have what is called a heterodont dentition. Instead of a whole bunch of little pointy teeth, they've got different kinds. Incisors here, canine, premolars, and molars. And particularly the premolars and molars, they've got lots of cusp. Mammals also have a parasagittal posture. Their legs are arranged right underneath them instead of the sprawling posture like lizards and salamanders have. Mammals also have a different jaw joint than just about any other vertebrate. It's between the dentary bone in the mandible and the squamosal bone in the skull. And furthermore, if you look in their ear, they've got three bones in the middle ear: the malleus, the incus, and the stapes, the hammer, anvil, and stirrup. So, why do we have this weird middle ear with three bones? All the better to hear you with, you might think, but no, probably not. It's mostly just an accident of what's going on with the teeth in mammal evolution. Let's have a look. In the evolutionary origin of mammals, the teeth, chewing, the skull structure, and the ear are all tightly integrated as they change. What you're looking at in this diagram are four animals: a true mammal, in this case a coyote, a close relative, a cynodont, the genus Thrinaxodon, a more distant relative, a Theracocephalian, and a pelycosaur, an even more distant relative, Dimetrodon, the big sailback thing. Look at what happens. Mammals are part of the clade Synapsida. Synapsids have one temporal fenestra on their skull. It's right here. It's pretty obvious in Dimetrodon. Look at what happens to it as we come up towards mammals. The lower bar of it moves backwards and bows out. That's what's going to become the zygomatic arch, or the cheekbone. As we come up here into mammals, we see it looking like a cheekbone. No longer looks like a temporal fenestra. At the same time, look at the side of the jaw. Up here, this big indentation is where the masseter muscle fits. Also look at the bones in the jaw. Dimetrodon has a dentary, plus it has an angular, a splenial, and other bones in it. It's a multi-boned. Whereas when we get up to the mammal, the coyote, there's only the dentary. And remember, we've got a dentary squamosal joint. Here's a mammal phylogeny. We've got our three groups: the monotremes, the marsupials, and the placentals. Marsupials and placentals are closely related to one another. They are collectively called the theria, as in metatheria marsupials and eutheria placentals. And the three groups together are the Mammalia. Mammalia is the name for the crown group, where crown group is the phylogenetic term for the last common ancestor of the living members of the group and all of the descendants. So those three come back here. Their more distant relative, Morgan-Eucodon, we think of that as a mammal. It has a dentary squamosal jaw joint, but since it's outside the crown group, we reserve the name Mammalia for the crown group. And so this larger group, including a bunch of extinct forms, is called the Mammaliaformes. It's the last common ancestor of Morgan-Eucodon and living mammals and all the descendants of that. And then there are cynodont like Thrinaxodon and Dimetrodon out here. Okay, let's look at some of the fossils here. This is a phylogeny from Lowe showing Mesozoic mammals, 251 million years ago to 65 million years ago. We think of the Cenozoic as the age of mammals. It was for the placentals, here in red, and the marsupials, here in blue, but there were a whole bunch of Mesozoic groups. So let's orient ourselves. We've got Mammalia here, placentals and marsupials here, the theria. Their closest relatives, the monotremes here, which define Mammalia. All of these yellow groups are extinct Mammalias. Then we've got Morgan-Eucodon down here. This whole group is Mammaliaformes. The blue ones are Mammaliaformes, but they're not Mammalia. There's a whole bunch of them. We're not going to get into all of them, but notice something about their diversity through time. Early on here we have Docodonts, australosphinidins, and eutriconodonts. Later we have multituberculates being one of the more diverse groups, and then we have placentals and marsupials. Here we've got the first mammalia form, Morgan-Eucodon. Name is Welsh because it's from Wales. It's from the late Triassic, evolved not long after the first dinosaurs. Morgan is basically morning in Welsh. Dawn, we already meant teeth. Morgan-Eucodon is the dawn tooth, the first mammal, or the first mammalia form to be more precise. Here's its lower jaw. It's mostly made up of a dentary. We've got kind of a heterodont dentition here, and we've got these thin little bones that are the remnants of the posterior bones of the jaw, which are now becoming more closely associated with the ear. This one's holding the eardrum. Docodonts. Look at this one from China, Middle Jurassic, a docodont. It's just like a beaver. It's got a big wide tail, which is preserved. You can see the soft tissue here. Functionally like a beaver, not an insectivore, but also not a rodent, not a placental, not even a mammalia, an extinct docodont. And what's this? Looks like a flying squirrel, you say? No, it's a eutriconodont. This is a member of the crown group Mammalia, but it's not a monotreme, it's not a placental, and therefore not a rodent, and therefore not a flying squirrel. This is a eutriconodont. This one from the Jurassic of China as well, and it was a gliding animal. Multituberculates are another fine mammalian group named after their teeth. Tubercle means cusp, multi means multiple. These animals were typified by having especially upper molars that had many, many, many cusps on them. Multituberculates belong to the crown group Mammalia, but they are not part of placentals, marsupials, or monotremes. They're completely extinct. They were very diverse in the late Cretaceous and the early part of the Cenozoic. They had this very curious lower premolar. Some of them did anyway, which is called a plagiolacoid premolar. Some actually kangaroos have a very similar morphology to this. This is one from North America. Shown climbing down a tree. It could reverse its hind limbs, move very much like a squirrel. This is the oldest multituberculate here, showing being chased by one of the feathered dinosaurs. I want to briefly mention the author of Camptopatar, Zofia Kielin-Jaworowska, who not only contributed to our knowledge of multituberculates, but was one of the greats of vertebrate paleontology as a whole. She was born in Poland in 1925 and grew up during the Second World War, which saw the partition of her country and the start of the communist government there. Getting an education was not easy in those years, and she had to sneak some of it in illegally. She became interested in evolution and became a paleontologist, getting a degree in 1953 and working on, interestingly, Paleozoic invertebrates and especially trilobites. Through those same years, she learned about the expeditions to Mongolia by paleontologists from the American Museum of Natural History first and the Soviet Union later. Sophia and her husband responded to a call for proposals for work in the new Communist Republic of Mongolia. Knowing of the American achievements there in dinosaurs, they proposed to find Mesozoic mammals. This invertebrate paleontologist soon learned that she'd been funded to search for vertebrates in the Mongolian desert, and they found amazing things. That was the beginning of a very successful career. She published more than 200 papers on multituberculates and Mesozoic mammals and on the Mesozoic at large. If you're interested in more about her story and about Mesozoic mammals, check out her book published by Indiana University Press. Mammal teeth, they're complicated because you can identify a mammal down to the level of species pretty much just from a single molar. Here are diagrams of tribosphenic molars. This is the ancestral mammal tooth type. This is an upper, this is a lower, 3 major cusps here on the upper, 3 major cusps here on the lower. On the uppers, they all have the word cone. On the lowers, they all have the word conid. It's these 3 cusps that form the triangle of the upper tooth. All the complexity of the mammal molar tooth is related to how a mammal chews. As the teeth come together, they interlock. Here you see a classic diagram from Crompton Jaime showing how tribosphenic teeth fit together.